Hello and a very warm welcome to the theIAShub. This is the 6th lecture of the basics of geography. See, until last class we were discussing about the plate tectonics and I have given you a brief idea about the plate tectonics. So many students have asked me regarding, sir, let's get into the monsoons topic. काफी confusion hai. So today one of the most complicated topic जो है monsoons, we are going to deal with that, and that too the Indian monsoons. So broadly speaking, we'll be covering up this monsoons in a very lucid manner, in a raw language where I can give you the conceptual clarity, and in the main classroom when we get in, where we'll learn it in a very detailed manner. Right? And if you do have any doubts, you can also post them into the comment section. Right? I'll be addressing them. Now coming to the topics of monsoons. So see, before you have to understand the concept of monsoons, in the previous classes we have dealt with the concept of easterlies, westerlies. You already know what are easterlies, what are westerlies. This we have learnt, and we have also learnt what is Hadley cell, what is Ferrel cell, right? And this we have dealt in the class number 2 and class number 3. If you do have any doubts, you can go and watch in this playlist itself. Now come back. So before we start, first let me tell you what are easterlies and what are westerlies, and after that we'll venture into the concepts of monsoon. Broadly speaking, there are some permanent winds which are present on the earth. Now these permanent winds, in the previous class we have discussed that there are easterlies, there are westerlies, and there are polar easterlies. Now they are called with different names, right? You might have heard about trade winds, you might have heard about planetary winds. Easterlies kya hota hai, westerlies kya hota hai. They are nothing but the same, they are called with different names. I hope there is no audio problem online. If you do have, please let me know. Please comment in the comment section. Right. So, see, easterlies are present between 0 to 5 degrees north. Sorry, 5 degrees se lekar until the mid latitudes around 30 degrees north tak, and then 5 degrees south to around 25 to 30 degrees south. Now these winds are called as easterlies because they seem to be coming from the eastern side. Right? This is what we have discussed. And then where are westerlies present? Westerlies are present in the subtropical high pressure belt se lekar subpolar low pressure belt ki beech mein. That means it is in the latitudes of 30 to 60. Again, beyond 60, you have winds that are coming from the eastern side. They are called as, again, polar easterlies. Now, monsoon of India is one of the most complicated topic. Why? Because the general pattern of the winds are changed on a seasonal basis. See, whatever you see it on the board, this is called as global atmospheric circulation. Now, what is this global atmospheric circulation? How the winds are moving on the surface of the earth. Now, there are winds which are present at the lower level, 0 to 3 kilometers tak kuch winds present hai, and beyond 3 to 10 kilometers above the surface of the earth, there are some winds present. Now, these winds which are present above 4 to 5 kilometers on the upper reaches of the atmosphere, they are called as upper atmospheric winds. And those that are present 0 kilometers se lekar 3 to 4 kilometers tak, they are called as lower surface winds or surface winds. So here I have introduced to a term called surface winds, and then I have introduced to a term called upper atmospheric winds. There are a lot of variations in the Indian monsoon with respect to this surface winds as well as upper atmospheric winds. Come back. See, broadly speaking, here you have this as equatorial low pressure belt, which is present between 0 to 5 degrees north and 0 to 5 degrees south. And above that, you have the next pressure belt that is present is subtropical high pressure belt, and then you have subpolar low pressure belt. You also know these kind of winds are also, pressure belts are also present in the southern atmosphere as well, southern hemisphere as well. Look, these are your easterlies, right? They are also called as northeasterlies bhi. They are also called as trade winds, or they are also called as easterlies. Okay? Now, these easterly winds are the major reasons why you have the monsoons onto India. But as this ITCZ zone, the zone which is present in the center is never constant. It keeps on moving with the seasons. Okay? This is also called as doldrum, I think we have learned this. ITCZ zone. Now ITCZ zone is nothing but intertropical convergence zone. Now what is this intertropical convergence zone? Winds from both the tropical regions until 24-30 degrees, the winds are coming from both the directions and they join here. So that's why this is also called as ITCZ zone. But you will not find this ITCZ zone in a straight line. Why? Why? Because here you need to understand a concept called specific heat. Okay. I think I have explained the concept of ITCZ zone in the previous class. Okay, fine. See, here you need to understand a concept called specific heat. You see, across the, let's see, the amount of land mass that is present at the 30 degrees north latitude. Do you see? There's much of the land that is present at the 30 degrees latitude, and then there is equivalent amount of land here, and then there is ocean. So, suppose I have a bowl of water which is 1 liter and I have an equivalent volume or equivalent weight of sand or land. If I give heat to both of them, which will get heated fast? Sand or water? Sand will get heated fast. Why is the water taking time? It is because specific heat of water is more. Water takes more temperature to heat them. Why? Because water can transfer heat by moving in every direction. The molecules in the water can move, but molecules on the sand cannot move, or rock cannot move. That's why rock gets heated fast. Now you see, if I have water here and I have land here, right? This will get heated fast. This will get heated little slow. Now by this logic, the heating variations at the tropical regions are completely different. So you come across the intertropical convergence zones. The intertropical convergence, they do have a very varied pattern with respect to seasons. You see, this is the ITCZ zone. Okay? Intertropical convergence zone, जहाँ पे both the winds, imagine the winds from the northern hemisphere and the winds from the southern hemisphere, they come and meet here. Wherever the winds from the southeasterlies, these are your easterlies, right? These are northeasterlies, these are southeasterlies. Wherever they do come and meet, that is where the ITCZ zone is, right? Now in this ITCZ zone, it keeps on changing. Look, this is the month of, ये कौन सा month है? Looking at, can you guess which month is this? This is the month of June and July. This is the month of December. Where do you find the ITCZ zone in the month of December? In the southern hemisphere. Where do you find this ITCZ zone in? Why is it present in the northern hemisphere? Because we have learned a concept called seasons. In that seasons, where do you find the sun's rays directly falling on the surface of the earth? At which latitudes? See, in the month of June, the sun's rays, imagine this is your sun. The sun's rays will be falling without directly at the Tropic of Cancer, June 21st pe. But the same sun's rays will fall directly in the month of December at Tropic of Capricorn. That's the reason why your ITCZ zone also shifts. Now what is this ITCZ zone? ITCZ zone is nothing but a low pressure area. ठीक है, काफी low pressure area है. We have already learned the concepts of what is low pressure, what is high pressure. Low pressure पे किस type की winds होगा, high pressure पे किस type की winds होगा. Now monsoons are very advanced topics, and till date no one in India nor in any world, they did not understand the complete crystal clear clarity, or they did not have this clarity of monsoons. Why? Because it is very dynamic. You will get to understand this in some time. क्योंकि ये जो monsoon की topic है, आज भी there are many models which are not being able to predict because global climate change phenomena is there, El Nino sunne mein aaya, La Nina sunne mein aaya, and then you get to see triple dip El Nino, triple dip La Nina. There are many terms which you have to come across, Indian Ocean dipole. So that's why many phenomena are present here. Now coming back to the concept of monsoon, here, see, broadly speaking, ये आपका in ideal conditions, this is how the winds move. But आपका जो ITCZ zone है ना, it is never a straight line because there is somewhere ocean here which is heated at a different temperature, different rate. There is land here which is heated at a different rate. As the land gets heated fastly and water gets heated slowly, that's why the pressure belt which is formed. What is this? This is nothing but equatorial low pressure belt, and this is also nothing but the doldrum. This is also nothing but the ITCZ, and this ITCZ, it moves in the month of December, it will be in the southern hemisphere. In the month of June, it will be in the northern hemisphere, right? Number one. So coming to the monsoon concepts, monsoon is a global phenomena. The applications of monsoon are a global phenomena. Now this monsoons can be divided into actual monsoons, pseudo monsoons, and that monsoons are not just confined to the India, they are also confined to little parts of Africa as well, right? But before we go ahead, what exactly is monsoon? Can you define me what is monsoon? How do you define monsoon? Rainy season. So there is rainy season in the month of December also, January, in the northern hemisphere, if not in the northern part of India, and if it in the southern regions, you will find the Kerala will be receiving in the month of June. It's not rainy season. Monsoon is nothing but seasonal reversal of the winds is called as monsoon. The real definition of monsoon is that mausam, seasonal reversal of the winds. Now, what are these winds doing? You got to learn about the global atmospheric circulation. We'll once go back and try to understand here. You already know this is equatorial low pressure belt. The winds rise, and once they rise, they diverge in both the directions, and then they sink at the subtropical high pressure belt, and due to Coriolis force, this is how the winds travel, right? Clear? And similarly, this is the same position how the winds travel, right? This is the direction of the winds. Now, these are your surface winds, and this is your upper atmospheric winds, as traditionally we have learnt. And what is this cell? Hadley cell or Ferrel cell? What is the Hadley cell or Ferrel cell? Is this Hadley cell or Ferrel cell? Is it right? Is it right? Online? Yes. Hadley cell, it is right. Hadley cell and Ferrel cell. Now, here, as the winds starts to move with respect to the ITCZ zone, that is what they bring the monsoon to India. Now, in the ideal condition, you see, if this is our India, do you agree? Now, on the India, let me zoom it. This is your north, south, east, and west. You tell me what is the direction of the winds. If I broadly speak, how is the direction of the winds are traveling onto India? In the north, it is northeasterlies, right? This is southeasterlies. So, let me show you, in the ideal conditions, your winds will be traveling in this direction. If imagine, agar aapka ITCZ zone, if it is ideally on the equator, which is generally not, the winds will be coming in this direction, right? Ideally, I'm telling you ideally. But ITCZ zone is never in this way. Your ITCZ zone in the month of June and July, it is present here. Right? So south of the ITCZ, what kind of winds do you have? Southeast trade winds or southwest winds? I know there's a lot of confusion, right? So wait for some time, you'll get the complete picture clarity here. Before that, let me give you a small introduction regarding the monsoons. See, monsoons study can be done by one. There are multiple theories in the monsoon. The first theory is thermal theory. ठीक है? Second theory is nothing but ITCZ zone. And these are the old theories. ठीक है? Now there are some new theories which tries to explain the monsoon. That is El Nino and La Nina, Indian Ocean Dipole, now old theories are also called as classical theories, and these are called as modern theories, right? These are classical theories and these are modern theories. Now there is a fundamental difference between what is a classical theory and what is a modern theory. ये जो classical theories है ना, ये काफी पुराना theories है. It was given in the year 1900s, 1890s उस time पे. But आज भी most of the textbooks they did not update themselves, right? Now coming to the first theory, thermal theory. See, thermal theory ये कहता है the water gets heated at a different time and the land gets heated at a different time. If you take India, imagine our India, it is like this. ठीक है? So imagine if this is your India, you have ocean on either sides. See, the thermal theories generally believed that much of the water, it gets heated at a different time and land gets at a different time. Suppose, you see, there is sun rays falling onto the India during the times of summer, the sun rays will come and heat India. This is land. Land gets heated quickly, right? June, July, August में land तो बहुत गर्म है, but लेकिन पानी is not that hot. So they say that there is rise of wind which is happening on India. So because of that, there is a gap that is created over India, or else the wind rises. As the gap that is created, the wind from the sea will start towards India. This is what the general belief which used to be believed by the early scientists. ये thermal theory है. Thermal is the temperature is the only factor which they thought. Other than that, they thought nothing else would play a major role. This is called as thermal theory. ये thermal theory काफी पुराना theory है. उसके बाद आया था, that is ITCZ zone, right? ITCZ zone is the intertropical convergence zone concept. ठीक है? Now see, ITCZ zone is the next theory, but आज भी ITCZ zone theory is not a valid theory. Our today's theory is more specifically interlinked with the concepts of jet stream. एक jet stream theory भी है, role of jet stream. ये सब चीजें involved होता है हमारा monsoon में. But come back to the ITCZ zone. ITCZ zone में ये theory it says that there is a zone called ITCZ zone, and because of that ITCZ zone shifting phenomena, why is it shifting? It is because the sun's rays are falling at a different latitudes. That is the same reason why the ITCZ zone keeps on shifting. Now what is ITCZ zone? Is it a high pressure zone or is it a low pressure zone? Why is it a low pressure zone if it is a low pressure zone? I asked you a question, is ITCZ a low pressure zone or a high pressure zone? It is a low pressure zone because here the wind rises, right? यहाँ गर्म हो गया, एक pressure belt बन गया. Now this pressure belt, here the wind rises, right? And what is this intertropical convergence zone? Now in the previous classes I have also told you about a jet stream, right? Where are jet streams present? Jet streams are present between Hadley cell and Ferrel cell, which are present here, and there is a jet stream which is present here. Now these jet streams, at what height do they travel? Right? कौन सा height पे travel करता है? Above 8 to 10 kilometers height पे, right? above 8 to 10 kilometers height, varying between 6 to 10 kilometers की range पे your jet stream keeps on traveling. ये एक jet stream जो है, it is actually a three-dimensional pipe. Imagine there is a pipe which is moving with meandering. It is like it has a length, breadth and width. It goes up and down like this. And at the same time, if you look from this angle, that means you turn like this, it is your jet stream also moves in this direction. That means it swings, sine wave banata hai, or else it makes a trough and it makes a crest. Trough and crest in one direction, and the other way it also moves in the troughs and crests in horizontal and vertical manner. Now that is the nature of a jet stream. ये जो jet stream जैसा winds है ना, they are present above 8 to 10 kilometers or higher atmosphere में present है. ये season के हिसाब से they also shift. Imagine if your ITCZ zone, if it has moved little northern, don't you think that this entire system moves little north? Yes, it moves little north. Now come back, I was talking about the concept of the thermal theory and the ITCZ zone theory. Now in the ITCZ zone theory, your ITCZ zone, it keeps on changing its position. Now how does it change? It changes like this. See, these are your jet streams. Just a minute. Your ITCZ zone in the month of June, it is here. It is December. So let's redraw this and recreate this, how exactly you will find the changes in the monsoon. Now, see, this is the general traditional way which we read, but imagine the same thing. This ITCZ zone has now shifted its position till here, right? And where is India? India is here. Okay? And somewhere here, this is your Himalayas, right? This is our ITCZ zone. Now, south of ITCZ zone, what kind of winds do you have? Easterlies. Here also, easterlies. But you know the concept of Coriolis force, right? What is the direction of the Coriolis force in the northern hemisphere? Suppose this is your equator, right? ये आपका equator है. Suppose if there is a wind, imagine this is your equator and there is a wind that is traveling in this direction, but it has crossed the equator. What will be the direction of the Coriolis force? Towards the right in the northern hemisphere. So the same wind, what does it do is it deflects towards the right. Right? So all these winds, while they come, they deflect towards their right. Any wind which travels towards once a southern hemisphere wind, if this is your southern hemisphere, this is your northern hemisphere, any wind, when they cross the equator, their direction also changes. Why they change? It is because Coriolis force, as simple as that, right? Now, but why is the wind moving towards that direction? Where are the winds going? The winds generally tend to go towards the ITCZ zone. Now, that is the general traditional concept of ITCZ. Imagine that ये जो winds है, now these winds, this is your equator, and then you have the southeasterlies, ठीक है? These are your southeasterlies. Clear? ये आपका southeasterlies है. But where are the southeasterlies going? They generally go to the ITCZ zone, right? Now for these winds to reach this low pressure zone, because what do? They have to cross the equator. So once they cross the equator, this is the direction of their wind. They finally go and reach here. Now this wind, it turns like this, it goes like this. Do you understand what I am trying to tell you? What is the direction of this wind? Imagine ये जो pressure belt है, ये आपका subtropical southern hemisphere में. Now this height is also little lowered. Now see, can you see the difference between these winds which we have studied here and then the same winds which are southeasterlies? What are these winds? ये जो winds है southeasterly winds. Now the southeasterly winds, what do? They changed their direction. The same southeasterlies, they cross the equator to reach the ITCZ zone, because sun in the northern hemisphere during the month of June will be directly falling at the Tropic of Cancer, right? So that's the reason why after they take the turn, or after they cross the equator, they take a turn. And with that turn, all these winds will go and reach the Tropic of the ITCZ zone. In this due process, the southeast trade winds, now you see, what is the direction of the wind? ये north है, south है, east है, west है. What is the direction of these winds? This with respect to India. I'm talking about the direction of these winds. South. What is the monsoon name of India in the month of June? In the month of June, what kind of monsoons do you have? Online, Chahat Goyal, southwest, because direction changes after crossing the equator. Very good. Amit says, Kana says, yes, westerly. Chinar, the pride of Kashmir. Nice. We have an online student named Chinar, the pride of Kashmir. So, westerly, yes, they are coming west, but lekin south or west, na? Dekho. Earlier, the direction of the winds here is southeasterly. ये जो direction of the winds है northeasterly, right? Look, the same winds today in the month of June, they change their direction. ये north है, south of India, to be more specific. Now, what is this direction? This winds. It is southwest. Now, the name of the monsoon of India in the month of summers is monsoon. Right? This is what is southwest monsoon. But is the ITCZ zone only the reason you have this monsoon? We were thinking that earlier, until before the 30-40 years before, we were thinking that ITCZ zone is the only reason. क्योंकि हमें ज़्यादा research नहीं था, 40-50 years before we did not have much of a research. We were only believing that यही है हमारा reason. But later with the advancement of technology, Second World War के बाद काफ़ी कुछ नए innovations हुआ था. We got to send our satellites into the space. Our first satellite we sent 1960s. And then we got to understand, oh यार, जो हम सोचते हैं ना, वो नहीं है. Today, if I am able to show this piece of earth to you on the screen, with sizable varied measurements I am able to show you, and I can also show you the clouds. Why? It is the work of the satellites. We got to learn the advancement of data over a period by studying the weather patterns, the meteorological department's integration. Today we got to learn our monsoons are not just because of the ITCZ, it is also because of the concept called jet stream, Indian Ocean dipole, La Nina and El Nina, ये सब intermixed कारण. Right? Now come back. Now this is the case of the southwest monsoon. ये कौन सा month में है? In the month of June it starts. But what about the rainfall in the December? December की time पे ITCZ zone जो है, it completely changes its position. Again, see, the ITCZ zone in the month of December, it will be here. This is your equator, right? The ITCZ zone will now shift its position. Let me draw. This is your equator and Tropic of Cancer. Here you have your India. See, आपका ITCZ zone जो है, it is somewhere in this southern hemisphere. It is like this. South of the equator, somewhere it will be. So, what about the winds? Here the winds will be what is the direction of the winds now? this is north, this is south, and then east, west, it is northeast. So in the month of January or December, we have northeast monsoons. Right? Clear? This is how the northeast monsoons are there. But इसको ये भी कहा जाता है, they are also called as retreating monsoon. Why are they called retreating monsoons? So this northeast monsoon is also called as retreating monsoon. Why? Why? Because can you see earlier what is the direction of the winds? Now let me take a different color. Now what are the winds which are present north of this ITCZ zone? What kind of winds are present here in the month of June? Aren't they northeasterlies here? ITCZ zone यहाँ तक था. Why are they called retreating monsoon? Because see, in this case, don't you see the winds which are present of the southeasterlies in the form of southwest monsoons? They are present till the ITCZ zone. Yet धीरे धीरे ना, the advancement of the northeast monsoon starts. The advancement of this northeast monsoon starts. At the same time, ये जो winds है, they move back. Where are they moving? Currently, today, they are present here. In the month of June, the winds are present here. पहले कहाँ पे था? यहाँ तक था. ये पीछे चले गया. Don't you think that they went back? They retreated back. If I'm coming forward, this is called advancement. But if I'm moving backward, this is called as retreating. So all the winds which came till the Tropic of Cancer in the month of June, they retreated back. That means, look, today where are they? They retreated back. These southwest monsoons retreating back, and the advancement of the northeast happens. That is why it is also called as the retreating monsoon. Who retreated? Which winds retreated? The retreatment of the winds is primarily done by the southeast. Because we take reference as southeast trade winds. That is the reason why we generally study the monsoons with respect to retreating monsoon. ये है ITCZ zone, right? Now coming to the next concept, that is modern theories. हमने क्या पढ़ा था? There are two different kinds of theories. One theory talks about the thermal theory. The second one is ITCZ zone. Thermal theory, आज आपने कभी the concept of land breeze and sea breeze सुना है? Land breeze, कभी आप sea shore के ऊपर, if you are sitting on the sea beach, morning time the winds will be coming from the ocean towards you, but at the night time the winds will be moving in opposite direction. The concept of the sea breeze and land breeze also comes from the thermal theories. But modern theories, where do they concentrate? What are they demanding? Now they are nothing but the jet streams. So this we need to understand. Independently you cannot understand this. You cannot understand this independently. You have to understand them through an integrative manner. Now, to understand these theories, you need to have the conceptual clarity on few components. See, the conceptual clarity, whatever you require for this is here. So, firstly, you need to understand the concept of low pressure. Imagine I have an area. ये मेरा area, I have an area. In this area, the temperature is high. When the temperature is high, what happens? The air rises. ठीक है? The air rises. What kind of pressure do I have here? You have low pressure. Now in the low pressure, the winds will start to move from all the directions. In the previous class, I have told you, here the winds will start to reach here in all the directions. Right? This is low pressure, and then the winds come, they rise, then here they diverge. Right? Clear? Now this is a low pressure system. That means, broadly speaking, if I redraw this low pressure system, it will be the winds go and diverge in all the directions. ये आपका लो प्रेशर सिस्टम है. You understand? This is your low pressure system. Now, when you look this from the top, imagine when you are looking this low pressure system from the top, if you apply the concept of Coriolis force to this, how does the wind rotate? Will this wind rotate clockwise or anti-clockwise? Chalo, let's try to understand. So, if you understand this, only then we will be able to apply the similar concept onto the monsoons. The wind that has risen here, it will slowly start to experience the Coriolis force as well. Low pressure system pe, the wind will converge at the lower end, and then they rise, and then they diverge. This is how the divergence take place. Now in this divergence, this wind, it starts to turn towards the right. Coriolis force is towards the right in the northern hemisphere. So finally, what is the direction of the rotation? Tell me, clockwise or anti-clockwise? It is clockwise. Tick, 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 the clock moves like this, right? Suppose this is the rotation of the clockwise. Now this is a system of low pressure, right? So come back. Now we have studied about the concept of ITCZ, right? In the ITCZ, we were considering that ITCZ zone is the only reason why the monsoons are there. But later we understood that jet streams also play a role. El Nino, La Nina, Indian Ocean Dipole also play a role. Now here, jet streams are not the wrong concept, but उनका भी role होता है, लेकिन minimal role है वहाँ पर. ये हमें पता चला. ये minimal role है क्या? It's like this. Now take the concept of India. ठीक है? पहले आपको थोड़ा बहुत topography का भी knowledge होना चाहिए. You need to have the concept of topography also. See, broadly speaking, if you look into the India and the the southern part of India and northern part of India, our topography is like this. If you understand this topography, only then you will be able to appreciate the concept of monsoons, right? If you do not understand, it is very difficult for you again. Now, see, this is Tibetan Plateau. These are your Himalayas. Tibetan Plateau, on an average, the height of the Tibetan Plateau is somewhere around 4.5 kilometers, right, above the sea level. So imagine the height of Chennai is 0 meters. Now the height of Tibet is 4.5 kilometers. Kafi unchai par hai, right? So Tibet is considered to be the heat engine of the world during the times of summer. Agar ye garam hota hai na, it will start to evaporate at a faster rate, very, very faster rate. And come back, the major reason for the Indian monsoon system is because there is a low pressure system that has been generated over the Tibet. Now understand the concept of low pressure which I told you in here. Apply the same concept of the system of low pressure, whatever we have learned here. See, ye aapka similar kind of system, it will now be developed over Tibet. It's like this. See, here in Tibet, you'll understand that. Okay, let me use a different color. ये है आपका low pressure area. In the low pressure area, what happens? The wind rises, and then they diverge. The divergence is in every direction, right? The wind rises. Let me draw it here. Okay, let me use the red color pen. The wind rises, right? Now when the wind rises, average height is 4.5 kilometers, and When it is 4.5 kilometers average height, if the wind rises, till what height it can reach? Easily it can reach up to tropopause. ठीक है, tropopause हमने पढ़ा था, याद है? Tropopause तक पहुंच जाता है. Now in the tropopause, you will get to understand that beyond the tropopause the wind cannot rise. See here, look again, the wind starts to diverge. Is it right? Now, what is the direction of the rotation of the wind? Clockwise or anti-clockwise? So it is like this. You agree to me that you apply the Coriolis force, and finally, this is how the rotation of the wind happens. But here, you will get to know that there is a jet stream which comes and interact with the system. If you remember, there is a jet stream between Hadley cell and Ferrel cell. What was the jet stream called? It is subtropical jet stream. That is tropical jet stream. Jet stream, you will learn in the further classes in a very detailed manner why this jet stream has been formed. But lekin ye hubby intention is to give introduction to you, right? It is only giving introduction about the monsoons. If you understand, it is good. If you do not understand, then you'll have lot many doubts. Again, it is also an intention that you are open to the doubts. Come back. See, there is a jet stream. The jet stream which moves at a height of, it moves at a height of 8 to 10 kilometers above the sea level. Right? ये jet stream का नाम क्या? Subtropical westerly jet stream. This jet stream, it comes and interacts with this system. When it interacts, it is part of a jet stream will be flowing in this direction. Here the jet stream gets diverged. Okay, part of a jet stream will move in the similar direction, but another part of the jet stream will take a turn and then come on to India. Right? Got it? Now, why does it turn? Very good question. देखो, ऊपर rotation क्या है? Clockwise. The jet stream is coming and interacting with the system. Coriolis force is towards the right. When it has interact, the wind is moving at a very fast rate, irregular. For example, if I'm moving in this way very fast, all of a sudden there is a low pressure system. I've interacted with that and then it has moved towards the south. ये देखो, आपको ये जानना चाहिए, jet stream जो है, it moves on an average at a height of 10 kilometers. When you study the concept of vertical winds or thermal winds, ये जो winds which are moving at 8 to 10 kilometers, they do not have friction, right? You slowly change the direction, they move in that direction. Got it? So friction के कारण कोई भी direction अगर आप दिखाते हो, the winds move in that direction itself. And the other reason is that आपने कभी सुना है masculine high? What is that masculine high? See, masculine high is nothing but you will get to know in the further classes. यहाँ पे एक high pressure belt होता है, right? And because of that high pressure belt, some of the winds which are present here, they also travel in this direction and come towards India. Yes, they're all part. El Nino, La Nino, I'll come. Most likely we'll be dealing the El Nino class in the next, because El Nino is a very big concept. For that you need to understand the concept of oceans. El Nino क्या होता है ना? El Nino is a concept which is related with ocean and atmospheric phenomena. Ocean phenomena भी है और atmospheric phenomena भी है. It's like that. Now come back. Whatever the winds which I have drawn in the blue color, what height are they? 8 to 10 kilometers. ठीक है? आपको ये याद रखना चाहिए, ये 8 to 10 kilometers की ऊंचाई पर, this wind is also 8 to 10 kilometers की ऊंचाई पर, 8 to 10 kilometers. Now what is the height of this? Try to imagine it in 3-dimensional. ठीक है? 4 kilometers. Now आपका जो ITCZ zone है, I am drawing the ITCZ zone. Your ITCZ zone is here, which is present at what height? ठीक है. ITCZ zone कौन सा लेयर पे प्रेजेंट होगा? It is present at, your ITCZ zone will be present at a height of 0 to 3 kilometers. Got it? Yellow color is at the lower end, and the blue color winds are moving at the higher atmosphere. So broadly speaking, these winds, they do this, comes and it steers, and then it is the stronger the blue winds, the stronger the jet stream, it will come and sink. Okay, it will come and sink. Sink where? Yes. So imagine ये जो wind है, it comes and sinking. When it sinks, what kind of pressure it creates? High pressure or low pressure? It's high pressure, right? Why is that high pressure? In the previous classes, I told you that high pressure means much of the air is present at the lower end and less air is present at the higher end. If it is present at the lower end, it is because the air comes and sinks, and the black color winds which you are seeing, they move towards the ITCZ zone. This is where they come towards the ITCZ zone here. The stronger the jet stream, the stronger will be the monsoon. You know what is the average speed of this wind? Here it is near about 200 kilometers की speed पे चलता है, but लेकिन यहाँ पे पहुँचते पहुँचते ये 90 kilometers हो जाता है. क्यों? क्योंकि this jet stream got divided into two. A jet stream can be diverged, a jet stream can be combined, it can be diverged into two, it can rejoin, it can be a temporary jet stream. So what is the direction? It is coming from west to east, but this winds, what is the direction? It is coming, it seems to be coming from east. The name of this jet stream is subtropical easterly jet stream. Right? The same subtropical westerly jet stream have turned into subtropical easterly jet stream. And this is how you will get to see the monsoonal push because of the jet stream. Right? Now, what is the name of this jet stream? The name of the jet stream is subtropical easterly jet stream. Right? Other one is subtropical westerly jet stream has turned into subtropical easterly jet stream. This is the major role of the jet stream. Right? So ये jet stream जितना strong होगा उतना ही अच्छा monsoon मिलेगा आपको. Right? Why? Because this jet stream, if it is stronger and then comes and sinks, it will push those winds towards India. It is coming and then it sinks, sinking the black color winds which are present at the lower end, that is 0 to 3 kilometers. The cloud formations and all, they come onto India. Sinking because you need to understand there are cells that are formed. Dekho, for example, if the air rises and then the air diverges, till what distance they can go? After some time they cool. Whenever they cool, if they find a pressure system which is cooling, they come and sink there. That is the general tendency. Why do they sink? Is because the systems are present like that. एक cell बन जाता है ना, यहाँ पे air rise हुआ. And one more. Firstly, do you understand the concept of gaps in the low pressure? See, you need to understand why the air sinks and why the air rises. Firstly, imagine in this classroom, I started to give certain kind of heat to this room, increase the temperature. The air in this classroom will slowly start to rise. So ideally, when this air which is present at the lower end, if it is going onto the atmosphere, higher reaches, you should not be having any air to breathe. Is it like that? It should be like that. Ideal conditions mein, if in a closed system, suppose if I start to send all the air up, you should not be having any air to breathe. But on reality scale, it never happens like that. Why? Because the wind from other areas will come and fill the gap. Right? But where is this other wind coming from? Yes. If this class is low pressure, kahin na kahin, there is other areas which are having high pressures, that wind will come to this classroom in all the directions. Every direction the wind will come, and then it rises. So once the wind has risen to the top, it diverges. So it sinks somewhere to fill the gap here. The same air has risen, it diverged, and then it sinks. It is sinking because there is a gap that is created. So ये जो gap that create हुआ ना, there's much of air going up, and then the same air will come and sink here. It comes to fill this gap. So these black color winds, I'll name all these winds in the further classes, so don't worry. Just understand the concept in layman terms. So they go to the Tibet, but in reality they cannot reach that Tibet. Why? Beach mein Himalayas hai. That Himalayas do not let them to go and reach the Tibetan area. Okay. Online, I think there is some kind of issues that you are facing. Signal out range. Okay. I hope this is clear. Come back. So, see, if you have to redraw this, just a minute. Just a minute online. I hope the screen is now adjusted. Yes? Okay. Come back. Now let me redraw this. You'll get a complete picture. Imagine this is your Tibet, and this Tibet. Yes, please check. There's some issues with the. Agar right? Now imagine that this is your India. So the winds here, the jet stream, it travels and then it takes a turn around, then comes on to India. The turning around is somewhere at a 15-degree latitude. It's like this. It moves at, ये जो है latitude है, ये 15 degrees का latitude है. तो broadly, this is how it goes, and then it sinks. As it sinks, to be more specific, if I have to draw, let me draw it a neat diagram so that you will get a complete picture. Right. So this is how it takes, right? The turn is like this. So, and then it sinks here. As the winds sank, the same winds already you have your ITCZ zone somewhere on India passing through, right? The height is around 9 to 10 kilometers. These are your surface winds. The ITCZ is a low pressure system. The winds will go to the high pressure to low pressure, but already Tibet, which is a Tibetan plateau, which is there, ये एक tableland है, ये tableland already गर्म हुआ. So this is the role of a Tibet in the Indian monsoon. But our monsoon system does not end here. We also have the concepts of Indian Ocean dipole. We also have the concepts of the El Nino, La Nino, and jet stream. What we have learned is one jet stream. Now here, you'll also have a role of other jet stream, which is called as Somali jet stream. See, ये जो Somali jet stream है, as the winds rise here, it made a cyclonic circulation, and you found a jet stream. This jet stream, while it is traveling, it has taken a turn, and then it sank somewhere here. But here you need to know that there is a Somali jet stream which is present. ये local jet stream है, ठीक है? And this Somali jet stream will also intensify the monsoon of India. Now these are the two major jet streams which are acting on the India. These are the two jet streams, right? Now this is how the jet stream calculations are there onto the monsoons. Now next, coming to the concepts of Indian Ocean Dipole. Indian Ocean Dipole, El Nino, if you do not study oceanography, it is very difficult for you to understand that. And the concepts of El Nino is that it is part of El Nino Southern Oscillations. So in the Pacific Ocean, you will get to see some kind of oscillations. What is this oscillations? The oscillations are that some eastern part of the Pacific Ocean, usual times it should be colder, but for some reasons it will turn warmer. ठीक है? You go to the western part of the Pacific Ocean, that is nothing but Australia. Australia की eastern side पे ना, वहाँ पे the temperatures during the summer, it should be hot and there should be rain, it should be there. But those kind of conditions will be reversed. Now what are all this? We'll be learning them in the next class, and these are some of the basics of the monsoons. Though the technical reasons and the conceptual clarity in a raw format you have understood, but we have to write it with respect to the geographical language that in the classrooms we'll learn it. Now for all of this, the understandings have come from our class number 3, जहाँ पे मैंने pressure winds क्या है, high pressure क्या है, low pressure क्या है, how the atmospheric circulation take place. This is what we have learned. If you did not understand this, it means you do not have clarity in the atmospheric circulation, right? Do watch that video so that you will get a clarity here. So we'll end the class here and we'll continue with the next class, where I'll be taking up the concepts of the divergence of the continent and then the El Nino, La Nino. There are two different independent topics, but I wanted to give you the glimpse here, right? And if you do have any doubts, you have my contact number. Just drop a message, and my name is, right? Soon our batch is going to start. These are your basics. Get clear of these basics in the initial stages, right? Clear. Thank you. See you in the next class. Chinar, the pride of Kashmir.